So in this video, we're going to start Unit 3, and we're going to look at the relationship between graphs and the first derivative, and how we can use first derivatives to help us understand certain characteristics of the original graph. So we're going to look at this graph, and this is the graph of f of x or y. And we want to find the graph where y is increasing or y is decreasing. And this should be a pre-calculus concept, hopefully. So if we look starting kind of left to right, we can see, okay, our function is going down, which means it's decreasing until we get to -1. And then my function has, we call this a minimum. It's the lowest value in this region, lowest y value in this region. And then my function starts increasing, it's going up from -1 until we get to 1, which 1 we call a max. And at 1, then my function starts decreasing. It's going down from left to right. And we're going to describe this in terms of intervals. So we will generally use interval notation. There's 1 or 2 questions that uses inequality notation on the homework, but on the exam and on the written homeworks, you should use interval notation. So if I want to describe this, I would say my function is decreasing from -infinity, because we're going all the way, the arrow to the left means we keep going in the negative x direction, so it's going to -infinity until I get to -1. We always describe the intervals of increasing, decreasing with the x values. Okay, so I'm explaining where is it occurring. And then my function also starts decreasing when x is 1. So I'm going to put union with 1, and then it keeps going in the positive x direction. So we call that positive infinity. Okay, we would say my graph is increasing starting when x is -1 until we get to x is +1. And then we could say that there's a min at the point -1, -2, and a max at the point 1, 2. And these points, max and mins, are called turning points. That is where my graph changes direction. So it's changing from decreasing to increasing, and then at the max, it's changing from increasing to decreasing. So we want to look at, how does this relate to derivatives? Because we're going to use derivatives to find out this information about a graph without having the graph displayed. So the first thing we know is that a graph is increasing on an interval when it rises from left to right. So y is increasing and then the x value is increasing. If the graph is increasing, the slope would be positive. Okay, so it's the same thing as a line. We know that when our line is going up, the slope is positive, and that's same for any curve. Now, remember, the slope of the function is also the derivative. Okay, and so if the slope is positive, that means the derivative is positive. So we write that as f prime of x is greater than 0. And anytime you see that, that means my graph is increasing. Okay, so this indicates f, my original graph, is increasing. So if we say f prime of 2 is greater than 0, this means the graph is increasing at x equals 2. So if I go back to here, if I want to describe this in terms of derivatives, I would say that f prime of x is greater than 0 on -1 to 1. And so this is saying f prime of x is the slope. The slope is greater than 0, or the slope is positive from -1 to 1. And anytime we see that, that implies that my function f, I should write f, is increasing. And it's very important that you say which one is f and which one is f prime, because we're talking about two different functions. So we can do the same thing for decreasing. my graph is decreasing on an interval when it falls from left to right. So if for this case, the y values are going down or the f of x values are going down, but the x values are still increasing or going up. If my graph is decreasing, we say the slope is negative. So again, if I draw like a tangent line anywhere, my tangent line is decreasing, so that slope is negative. This means that the derivative is negative. And so we write it as f prime of x is less than 0. So again, if I go back to my graph here, what I would say is f prime of x is less than 0 on negative infinity to negative 1 and from 1 to infinity. So the one key term we use a lot in calculus is called critical points. So turning points are where the graph changes direction. It changes from increasing to decreasing or vice versa. So turning points, we said, occur always at the max or the mins. Now at a max or min, I go back, if I draw my tangent line at those points, so if I drew the tangent line here, we would draw a horizontal tangent line. And so at the max and the mins, the derivative is always equal to 0 because the slope of the tangent line at a max or min will always be 0. And so the derivative here is 0. So critical values or numbers are where the x value is where f prime of x equals 0 or f prime of x is undefined. We will mostly do this case in this class. We won't really deal with the undefined too many times, but if my graph looks like this, it's called a cusp. That is where the derivative would equal undefined. And this is A. So the critical values or numbers are the x value where it occurs. If I want the critical point, then I want the x and the y value. So I would find the x value by setting the derivative equal to 0 and solving it. And then I would find a is my x value. And I would plug a into the original function to get the y value, to get my point. And we'll do a problem like that in a minute. But if I come back here and look at my graph, we would say the critical points, and I use CP for that, are -1, -2 at here, and at 1, +2. Okay, so critical points occur at the max and the mins, or the turning points, and they're where the derivative is equal to 0. If the question said critical value, then I would just give the x value. I would say x equals -1 and x equals 1. So we're going to look at how do I find the critical value or critical number algebraically. So if we're not given a graph and we're just given the original function, I want to be able to find these just using calculus and not having to graph the function. So how we do that is we take the derivative. Okay. So this is 2x minus 2, and I always set it equal to 0. Okay, so critical values are where the derivative is equal to 0. I solve for x, so this is 2x equals 2, x equals 1, and so this is my critical value. This is where a possible max or min is going to occur, and we'll get into how we figure that out later on. Now, if the question says, find the critical point, I want the x and the y coordinate. So I found the x coordinate, but I have to find the y value. To find the y value, I always plug it into the original function f of x. Remember, f prime of x gives me the slope, not the y values. So I'm going to find f of 1, and it's very important that you label this so that I know where you're plugging it in. And so that's 1 squared minus 2 times 1, which is 1 minus 2, which is -1. So my critical point, again, CP, would be 1, -1.